The Opto Source consists of 9 bright LEDs, and they're arranged in the shape of the letter F, capital F. The supply for the LEDs is 2 AA cells, which are on the other side here. You can see the battery box, and we have a switch, and we can switch them on. Traditionally, perhaps we would use a candle or a carbon filament lamp as a source for basic optics experiments. This Opto Source is nice and bright, works in daylight, makes classroom management that little bit easier. So let's show this working. I'm going to turn it round, we'll switch it off for a moment, and we will use a biconvex lens. The focal length of this lens is 10 centimeters, and we will place it in a lens holder, and we'll make the separation between these greater than twice the focal length. So we want it to be greater than 20 centimeters to start with. So I'll place this at 25 centimeters. And to see the image that's formed, I've taken a piece of card and bent the end to form a stand, and I'll use this as my screen. So let's switch on. I'm going to move this until I get a nice sharp focus there, and you can see that the image is inverted in the vertical plane, and it's also inverted horizontally. It's nice and bright, easy to see even in the daylight here. So let's move the distance, or shorten the distance between the lens and the source to less than twice the focal length. Let's make it 15 centimeters. So we'll leave that where it is, and we'll move this to here. So there is the lens positioned 15 centimeters from the source, and I want to move this until again I get a nice sharp image. And you can see this time that the image is magnified, also inverted, laterally and horizontally. We can use this Opto Source to verify the lens formula, the 1 over f equals 1 over u plus 1 over v. We can calculate magnifications, and all of this can be done in the daylight. I'll just switch that off, and that is our Opto Source.